we're going to do notes. And then we have a practice Google form and a REPL. So we're starting Unit 9, which is on a topic called inheritance. And by the way, you can turn off your cameras if you want. You know, as with living creatures, inheritance has a lot to do with traits that offspring receive from their parents, you know, like eye color or hair color or how tall you are, that sort of thing. In Java, we use inheritance to build a hierarchy of classes that have similar characteristics. So I'm going to walk you through an example. Let's say we had a book class. We've done that before. And the book has two attributes, title and author. But then later we start wanting to work with graphic novels. And graphic novels have another attribute, which is the illustrator. It might be the same person, but it might also be a different person. By the way, just leave the AP Classroom assignment alone. We're going to do it another day when it's not broken. So don't mark it turned in or anything. Okay, so we have a book now, and it had author and title, and then we want to start working with graphic novels. We have this other attribute called illustrator. Now we could go back to the book class and add an illustrator attribute, but then think about it. We would have to change all our code in the book class, like the constructor and the toString, and we'd have to do all this stuff just to support Illustrator, which isn't even needed in a regular book. So instead, we can create a new class, and we tell Java that it extends the book class. So that's, I put it in bold here. Extends is the key word here. Java uses the extends keyword to tell to identify when there's a parent class and a child class. So what's great about this inheritance thing is that this graphic novel class gets to use all the attributes, methods, and everything of a book, but it also has the new thing. So in this context, book is the parent, graphic novel is the child class, and then we also call the parent class the superclass, and the child class is called a subclass. So child class has all the variables and everything that the parent has, but it also has its extra things. So it's not too complicated. Here it is in code, just the very start of it. So public class book, and it has private string title, private string author, and then I put a ... indicating there's a lot of other stuff in there. And then if we were going to write this graphic novel class, we would say graphic novel extends book. So you literally, in the title, like public class graphic novel extends book. And then we add the variable that we need. And then we deal with, you know, the other stuff down below. We'll learn about that another day. We're not going to write these classes today. So why do we bother to do this in Java? Well, inheritance helps reduce repeated code. So things that are shared across a bunch of different things in a hierarchy can just be in one place up at the top. Inheritance can also improve readability and help you get yourself organized. Makes it easier for a group to work on a project. I know everything we've been doing so far this year is, you know, alone, but you know, when you get a job someday, if you're a coder, you'll be part of a team, and then it's helpful to know which parts are doing what in a program. And also inheritance makes it easier to maintain code. So imagine if you had certain functions that had to be in every book. It would be a shame to have to put it in graphic novel and book and cookbook and, you know, 6 other different types of books that you're doing. It's better to have shared code in one place, so you can just fix it in one place, change it in one place, than to have it be all over the place. The College Board, again, made some great videos regarding Unit 9, and they posted last week. So I was watching the ones on 9.1 earlier this week, and here's a great example that they give you. Let's say we're coding some sort of online game, and there's characters in this game. There's musicians, comedians, dancers, and ballet dancers. And all types, these are all considered performers. So performers all have a name, an age, and a hometown. That would be attributes that they all have. And they can all practice and perform. Those are methods that they all have. And then specific types of performers have other attributes. So I'm going to show you on the next slide one way we could organize all of this. I just got this picture from their video. So we're going to say there's a class, a superclass or a parent class at the top called performer. And then underneath it, musicians are performers, comedians are performers, dancers are performers. And then we took dancer a little step further and added another kind of dancer, a special kind of dancer, a ballet dancer. So then here's some statements that are true about this diagram. Musician is a subclass of the performer superclass. See this right here? Musician is a subclass of performer. Comedian is a subclass of performer. Dancer is a subclass. And then ballet dancer is a subclass of dancer, not of performer. And these things can go on and on and on. I mean, I don't think it helps people to go on and on and on, but sometimes it is helpful. So the direction of the arrows. Yes, somebody just asked, so a class could be a subclass and a superclass at the same time? Yes. Yeah, it depends on the perspective. So the arrows in the diagram are supposed to point towards towards the parent. And one way to figure out if it's pointing in the right direction is to make a statement using the words is and see if it's true. So let's look right here. A musician is a performer. That's a true statement, right? So that means a musician is a child of the performer class. And a comedian is a performer. Yeah, I mean, if we're talking about someone, a professional comedian, they're a performer. So again, the arrow points up. Now, if somebody said a performer is a comedian, I mean, sure, that's a true statement sometimes, but it's not always true. And it's not true in this organization, right? A performer could be a musician or a dancer or a ballet dancer. So we're going to draw the arrow from the subclass to the superclass, or from the child to the parent. And this is a phrase helps you figure out if something should be in the hierarchy. Not everything has to be in the hierarchy itself. So here's a practice problem that was from one of the videos. I'm going to read through it. In a particular school system, there's going to be two types of people, students and teachers. And both types have a name, age, address, and an ID number. And then students also have grade level and GPA, and teachers are also going to have a hire date and a salary. So I want you to look at these 5 potential answers and pick out which one you think would be the right answer. That only one of them is correct. So we'll just take a minute. You read these. Okay. So I hope you chose B. Granted, you could create 3 totally independent, unrelated classes, person, student, and teacher, but they all would have these private string name, private string age, address, ID number, all these things at the top, which is all repeated. So the logic here would be, we've got a person class that has that stuff that everybody has. And then we have student, which has, GPA, grade level, and we have teacher, which has that other information. Yeah, some of these possibilities are just nuts. A student superclass. No, anyway, funny. Okay, so we're going to go through these. I again captured these from the video. There's the dude giving us the information. I'm giving him credit here, but look at this hierarchy. We have something, a lunch item, which is the parent of everything. Lunch items have two main splits. There's drinks and there's sandwiches. And then drinks are either tea or soda. And then there's all these different sandwich types. So I'm going to just pop through these quickly. Let's see if we think each one is true or false. You don't have to say on the chat. So you just say to yourself, a sandwich is a lunch item. Is that true or false? It's true. A drink is a soda. No. Look at the hierarchy. A soda is a drink. Soda is below. So drink can't be a soda. I mean, a soda can be a drink, but a drink can't be a soda. A hamburger is a lunch item. It's true. It's not we didn't say it extends lunch item, but it is a lunch item. A tea is a drink. Yes. A soda is a tea. No. A hot dog is a sandwich. Yeah. A lunch item is a sub. No. A sub is a lunch item. And a double hamburger is a lunch item. Yes. If I hadn't just eaten lunch, I would be hungry now. All right, so let's say we've been tasked with organizing. Oh, Logan wants to argue about whether a hot dog is a sandwich. It's funny, the guy in the video mentions, at least now I've finally answered this question. A hot dog is definitely a sandwich. I'd never heard of this argument before. I'm not going to take sides. Okay, so let's say we've been tasked with organizing the following things: zoo, snake, bear, animal, polar bear, brown bear. I want you to take a minute and try to sketch this out, like literally on a piece of paper. Grab a piece of paper and try to arrange this in a hierarchy that makes sense to you. And then I'll show you what I think to be the correct answer. All right, just another 10 seconds. All right. Here's what I did. And I admit, in a way, this was a trick question. A lot of people want to put the zoo at the top. Like, all right, well, the zoo's at the top, and in the zoo are animals. But imagine if we had animal under zoo. Could you say animal is a zoo? Nope. Now, a zoo might have animals. For example, it could keep track of the animals that are part of the zoo in an array list or an array. But that doesn't mean it has to be in the hierarchy. But yeah, snake is an animal, bear is an animal, Polar bear and brown bear both are subclasses of bear. Any questions on this? Don't feel bad if you put zoo at the top, but do be careful that you're asking yourself, can I say is a, like snake is an animal? Yeah, bear is an animal. Polar bear is a bear, right? Those are all true. Zoo, so superclass, the superclass, the highest class we have here is animal. Zoo is just another class. Like you might write a program that has zoo and animal and pet store as three different, totally different things. And zoo and pet store might have animals in them, but they don't have to be in the tree. They don't have to be children and parents. So I want you to answer this question for yourself. You don't have to say it on the chat or make any sort of visual symbol. But does this look like a valid class header? Class snake extends animal. I go with yes. It would be true to say snake is an animal. Is a, right? That's next question. Class brown bear extends animal. This would be no. Brown bear is an animal, but in the hierarchy, look at the picture, it extends bear, not animal. So we'd have to say class brown bear extends bear, not extends animal. Can we extend bear? Yeah, a brown bear is a bear. Let's go back to our performers example. And in fact, I'm zooming in on just the performer parent class and the comedian class below it, just so it's, I know it's pretty small on your screen share, but this little diagram here that again is from one of the first two videos for this unit. They've got variables up top, name, age, hometown, agent. Those are things every performer has. And then here are 7 methods that are available for every performer: get name, get age, get hometown, get agent, and then practice and perform, and then toString, so it'll print nicely. And then comedian extends performer, and it's got a variable called jokes, and it's got a method write jokes, because a comedian, in addition to being able to perform, has to be able to write jokes in this little simplified world. So I'm telling you over on the left, it would be legit in Java to make these 2 calls. Performer Paul equals new performer. So we created a performer, and comedian Chris equals new comedian. Great. And then I'm asking you to consider which of these calls would be legal and allowed. Could we say Chris dot get agent? And let me say, I should have probably put that into a print call, but just pretend we're printing the agent. Chris get agent. So remember, Chris is a comedian. So you're looking down here and there's no get agent method, but remember, children have all the methods and variables that are available that are in the parent. So yes, it's legal. And Chris.practice, yeah, the performer, any performer can practice. Again, it's a method in the parent class. The child class has access to it. Paul.perform. Yep, performers have a perform class, method, no problem. But if we try to do Paul.write jokes, I hope you can see Paul is a performer. Paul does not have access to the stuff down here in the comedian class. So that's not legal. Any questions? And that is it for the notes.